Hi everybody and welcome to this new video for the Festive Tech Calendar 2022. I'm Marco Obinu and I'm really happy to be here today with you talking about how Santa Claus can improve and modernize his own data centers thanks to Azure Arc. Before starting, just let me introduce myself. I'm an Azure technical trainer working at Microsoft, and I have a strong passion for all Azure related topics as well as for the data platform ones. If you want to stay in touch with me, just follow the link aka.ms Omega MATLAB, where you can find all my social media references. But now let's move on, introducing the issues Santa Claus is facing right now. You know, nowadays there are billions of people around the world, and Santa Claus is finding huge issues while trying to deliver all the gifts in only one night. He's struggling a bit while doing round trips between the North Pole and different locations around the world. To reduce the number of round trips, he tried several approaches during the time. He tried to add a couple of trailers to his left, just to carry on more gifts in a single trip, but unfortunately he hadn't the right driving license and the highway patrol immediately stopped him. So he tried to speed up the process by supercharging the reindeer. Well, I don't recall where, but I guess I've seen a similar picture before, and it wasn't a successful story. So, after those tentatives, he moved to a more robust solution that saves him a lot of miles by distributing several delivery points around the world. This required time, and not all the regions around the world were at the same technical level, so he ended in obtaining an hybrid environment where part of the infrastructure is composed by on-premises data centers, while others are distributed between public cloud providers like Azure, AWS, and Google Cloud. Unfortunately, a so heterogeneous environment in terms of infrastructural and software stack has a drawback. To manage all these different data centers with so many different tools, he had to move a lot of elves from the assembly line to the IT department. Now, these elves are trying to apply a coherent governance approach on a so different environment. Well, Azure Arc is the right service to mitigate this issue. Before seeing it in action, let's have a brief overview of this service. Well, Arc allows us to have a single pane of glass approach by leveraging well-known Azure capabilities and services to govern systems that can also reside outside Azure. It also allows us to implement Azure Platform as a Service services on any infrastructure by deploying those services on Kubernetes cluster, and when used in conjunction with Azure Stack HCI, it offers us a simple way to modernize our on-prem data centers thanks to a strong Azure integration. Here you can see the overall picture of the capabilities that are offered by Azure Arc. Well, by installing agents on physical servers, virtual machines, and Kubernetes clusters that are distributed both on premises or in other clouds, you obtain a representation of them in Azure. Once you onboard them as Arc-enabled resources, you can then use Azure services and capabilities like policies, monitoring, tagging, or other advanced services like Defender for Cloud and Sentinel, both to govern and to secure those Arc-enabled resources. Moreover, you can also deploy Azure Platform as a Service services like, for example, the Azure SQL Managed Instances, App Service, Machine Learning Service, and so on top of Kubernetes clusters that resides outside Azure. Another really interesting feature for Kubernetes is the ability to handle its configuration via a GitOps approach. You can simply use a Git repository to host the configuration of the cluster in forms of scripts, configuration scripts, and when you enable the GitOps feature on an Arc-enabled Kubernetes cluster, it receives the configuration from the repo and configure itself. Let's see how it works. First of all, we are starting with a Kubernetes cluster outside Azure that can be in different flavor of Kubernetes. We then onboard the cluster to Azure Arc and obtaining an Arc-enabled Kubernetes connected cluster. And then we create a cluster's GitOps configuration, and the Flux operators get deployed on the clusters and start listening on to the repository with the application code. Then Flux initiate the application deployment on the cluster, representing the desired state. When we update the application, creating a new application version and merge changes to the repository, Flux pick up the changes and the Flux operator initiates a new application version deployment on the cluster while removing the old version of application pods, resulting in a new desired state. Now it's time to see Azure Arc in action, and to deploy a simple Arc-ready environment, I used a super interesting project called Arc Jumpstart. This is the homepage of the project where you can find several jumpstart scenarios that allows you to test different Azure Arc capabilities and functionalities by simulating environments with Azure resources. In my case, I just used a Jumpstart Arcbox scenario that is available in different flavors. There's an Arcbox full experience where you can deploy a complete environment that allows you to test all the Azure Arc capabilities, including the management tasks of Azure Arc enabled servers and so on, the GitOps features, as well as also the platform as a service services deployment on top of Kubernetes clusters. Then there's a 90 Pros version that is the ones I deployed for my demo environment, where you have the opportunity to test all the management features on Windows virtual machines, Linux virtual machines, and a SQL Server virtual machines. Then there's a DevOps scenario where you are testing the GitOps experience, and finally an Arcbox for data hubs where you are testing the deployment of Azure Arc enabled SQL managed instances on top of Kubernetes clusters and so on. When we move into the Arcbox for IT Pros experience, you can find here the instructions to deploy this complete environment, where, as you can see here, we are deploying a quite big virtual machines that leverage nested virtualization to host several guest virtual machines, including a SQL Server 1, a couple of Windows virtual machines, as well as a couple of Ubuntu virtual machines, so Linux virtual machines. And then with this deployment, we will be able to test the management operations, like using, for example, the monitoring tools, the Defender for Cloud experience, and so on. This is completely handled and managed by the template you can deploy by following these instructions. Now let's jump into the Azure portal and let's have a look to the resource group that is created by the deployment. And here you can find all the resources that were being deployed by the ARM or bicep template, depending on what you choose to deploy. Now here I am using a Bastion host to connect the virtual machines that act as an Hyper-V node and hosts all the guest virtual machines. As you can see here, we have a SQL virtual machine, a couple of Ubuntu Linux virtual machines, as well as a couple of Windows virtual machines. If we jump back onto the portal and choose the virtual machine from the resource group, we can see in the networking sections that there's no public IP associated to the virtual machine. So there's no direct entry point to reach the guest virtual machines on top of the host virtual machine. Now, if we look here into the resource group, we can find the representation of the Arc-enabled systems that were registered during the deployment. We can see here a Arc-enabled servers for the Ubuntu virtual machines, as well as for the SQL VM and the Windows VM. And we also can see a SQL Server Azure Arc resource that represent the instance installed on top of the SQL Server virtual machines. If we jump inside one of these VMs, we can see just the some of the details of the virtual machine, like the computer name, the FQDN if it's joined to a domain, the operating system version, and the build number, and so on. We can also start interacting with the virtual machine through these different services, like the update services, the logs, and the monitoring insight, and so on. Let's jump to the Windows 2022 virtual machines, where I already activated the updates capability to see through this dashboard what are the missing updates that are available for that virtual machines. From here, we can also apply them via a one-time update or through a scheduled update during the time. Then we can also evaluate Azure policies against these virtual machines to check its compliancy, and we can use a software inventory feature and as well as the change tracking feature. And but one of my favorite capabilities we can leverage via Azure Arc is the opportunity to administer the virtual machine, the remote virtual machine, through Windows Admin Center. As you can see here, when I open the blade and I connect to the Windows Admin Center on the remote virtual machine, I can govern the entire virtual machine through the portal without having to open a specific port on top of the remote virtual machines. Here is the Azure Arc agent that is acting like a reverse proxy to allow us to connect to admin center via admin center to the remote system. As you can see here, we are facing the familiar Windows Admin Center experience, but we are inside the Azure portal and we are administering the remote system on top of the Hyper-V host. We can use it for looking at its performance, we can use a performance monitor, and we can open also a PowerShell section. Let me just log into the system and oops. And then we are inside the virtual machine through PowerShell. And if it's not enough for us, we can also open an RTP session from the portal directly to the remote virtual machines. Again, without exposing the port 3389 of the remote virtual machine. And as you can see here, we are inside of the virtual machine. This is the name of the guest virtual machine. We can achieve similar results on an Ubuntu virtual machine by leveraging the connect feature of the portal, where we can open an SSH session on top of the virtual machine through the Cloud Shell, for example. Yeah, I'm connecting to the Cloud Shell. I'm issuing the AZ-CLI command to open an SSH session, and then here is asking me for the password. And that's all. We are on the virtual machine Arcbox Ubuntu O2, and that's all. I'm connected again without having to open any specific port on top of the virtual machine. It's again the Arc agent installed on top of the virtual machine that acts as a reverse proxy for allowing this kind of communication. Then we can also leverage, for example, insights for monitoring purposes. But let's jump on a Windows virtual machine to where I already enable it to have a look at it. We can see performance data that comes from the virtual machine, but we can also leverage the dependency map capability that allows us to understand which are the services enabled on this virtual machine and who are the external systems that are consuming or contacting those services. This is really useful to depict a dependency map for our applications, especially when we plan to migrate this kind of application and we need to define who is talking with who in our systems. And again, as if we have a look um, into the resource group, we can also find additional resources like those SQL Server Database Azure Arc that are resources installed on top of the SQL virtual machine and that are exposed to the Azure portal thanks to the Arc agent. For example, these are databases that are attached to the managed SQL Server instance on top of the virtual machine, and that kind of representation inside the portal and inside the Azure in general allows us to collect properties of those resources. For example, here we can see the creation date of the database, the compatibility level of the database, as well as some of its properties. We can see that kind of information through the portal. We can also use that kind of information to create workbooks that collect those information in terms of inventory as well as in terms of data that comes from those systems. But we can also leverage the resource Graph Explorer to compose our queries in KQL, in Custo language, to obtain details from the onboarded systems. Here, under the hybrid and multi-cloud section of the categories, we can find different tables that expose the data we are collecting. For example, if we go here, we can open the all the resources with this query. We can open the resources where the type is Microsoft hybrid compute machines, and this give us all the details for the Arc enabled servers. And by looking at the properties of each row of each system that is sending us data, we can find all of its properties. We can then refine our queries to expose those data in a more suitable way for our purposes. And I think that's all for a really brief overview of this system. I strongly suggest you to open an Azure Start environment and to follow the instruction to deploy an Azure Jumpstart environment inside your subscription. Now let's come back to the slides to tell you something about the costs of Azure Arc. We want just to be sure that Santa Claus won't go bankrupt for using Azure Arc. Well, when we onboard a system to Arc, we obtain the control plane functionalities like tagging, RBAC, and so on for free. If we decide to leverage PaaS services like Azure SQL Managed Instances, for example, on our Arc-enabled Kubernetes cluster, we'll have to pay a fee for this kind of services. Well, this is similar to what happens in Azure for using the same services in Azure, but in this case, we won't pay for compute and storage resources since those will be provided by our hardware. And finally, once onboarded to Azure, to Arc, an external resource behave in a way that is comparable to a native Azure resource. For this reason, Arc-enabled resources billing is measured with the same metrics used for native resources while using Azure services like monitoring, Defender, Sentinel, backups, and so on. That means that an Arc-enabled resource for those services will cost you about the same amount of money you would spend for a native Azure resources covered by those services. In the end, Azure Arc is not so expensive for what it's offering us. Let's do a quick recap about this lightning talk. How Azure Arc can help Santa Claus? Well, it can reduce the effort for the elves by adopting a single well-known toolset composed by different Azure services to manage an heterogeneous system composed by different architectures wherever they are deployed. Then he can govern his Kubernetes clusters in a DevOps way, thanks to GitOps. And finally, he can innovate his existing architecture by leveraging Azure Pass without introducing too much changes to the current architecture. Well, I think that is a good deal for him to adopt the Azure Arc, since we also have seen a couple of seconds ago that this service is also quite cheap. Before leaving, I'd like to leave you a couple of links to go deeper on the topic. And here you can find again the link for Azure Arc Jumpstart, where you can find information about deploying a lab environment. Additionally, you can also find links for the Arc-related learning path on Microsoft Learn. Well, thank you for your attention. It was a pleasure to participate in this initiative. Let's see in the next festive tech calendar. So, bye bye.